to learn about SPSS, about the quantitative tools and about SPSS. So today's my topics are quantitative tools and techniques and introduction and application of SPSS. How do we do SPSS? So even before getting into the session, if people are finding difficult in installing your SPSS, you can also post a message in the group chat. I can try to help you if possible. So with this warm note, I thank Sage Summer School always. They are so considerate to help me to join this program. So I'm so thankful to the organizers and to the management for providing me a chance from sitting from Chennai, able to participate in such research workshop. So with this note, let me start sharing my session, my PowerPoint, and let us gear up. I'm trying to share my entire screen so that I don't have to go back and forth every time. Otherwise, it gets difficult if I change the screens. It gets difficult. Yes. So the topic given is quantitative data analysis tools and introduction. First, to begin with, we will have given a data. How do we see? See, we can have data in any field, but just having the data will not fetch the purpose of the research. So what are the techniques and what are the tools which will help us to develop the data further into a fruitful research? So for that, we need to understand the introduction part of how to handle the data analysis. I request the participants to kindly mute yourself. Thank you. So let us try to understand what is like data analysis. Data is everywhere. Data is omnipresent. So data helps us to understand, to interpret and conclude. Imagine that we are conducting, we want to start, we are not a proper researcher, we are starting, we want to start a business, we want to do some market research for the business. Let us take an example of a toothpaste. We want to start a toothpaste manufacturing company. For that, we want to know what is there in the market, what is the prevalence, which is taste, texture, what is that the customer expects, the consumer expects. For that, we can try to do some market research, collect the data from the consumers and the customers, and with the data, just having the data in an Excel format will not fix the purpose. So we have to analyze, interpret, and conclude, okay, what is the expectation of a customer? Which age group is preferring what taste? So what is the purchase intention? So a lot of answers can be found with such data analysis. So we need to apply proper tools for these. So there are two types of data. One is quantitative, the other one is qualitative. Qualitative we'll deal going forward in the next few sessions. We will deal with qualitative data. So quantitative data means the data which you can measure. For example, age, height, weight, whatever data you can measure is quantitative data. So usually some tools are there to analyze these quantitative data. If we have collected the data, after collecting the data, we try to put it in Excel. So Excel में सब कुछ print होने के बाद क्या करेंगे? We have to use some tools. So we will use SPSS or SAS or some statistical software will be of help. Also, sometimes we use Microsoft Excel to manipulate, to calculate, and to do the basic statistical analysis. And sometimes we need to visualize the data. We need to present it in a neat form. For presentation ke liye, we will use Tableau, Power BI, and Google Data Sheet. And also, अगर हमको वो data को collect करना पड़ेगा online पे, तो हम लोग Google Docs is a prevailing easy thing, and much more advanced things are SurveyMonkey and Qualtrics. Now, what is the purpose of a quantitative data analysis? As I mentioned earlier, we are going to have research regarding a toothpaste. What is the purchase intention? So, वो pattern को, वो relationship को, वो trend को understand करने के लिए हमको data analysis का मदद सीखना पड़ेगा. And for the quantitative data analysis, we will get lot of informations. We will try to understand what is the relationship of one factor on the other. Agar supply kam ho jayega to price ki wajah se kya ho jayega. So we can try to understand the relationship and the cause and effect thing with data analysis. Also, it helps us to test the hypothesis, to validate what is the purchase intention, whether the purchase intention is really having a consumer satisfaction. So we can try to correlate each and every variable with some other variable. So actually, quantitative data analysis means to find out something what is really we have to find out with the aim of the study, which will go with the aim of the study. We have to get the policy making. We should try to help the policy makers to decide something, and which will really help us with some evidence. We'll be able to take some decision. Usually, statistical important softwares are SPSS, SAS, and R, and even Microsoft are also useful usually. So, why do we need a data analysis? First thing is, as I mentioned, okay, let us take one more example. Agriculture. So we are finding two different plots are there, two different people. They are trying to find out, they are trying to do some production. Maybe we will take example of wheat. So they want to do a production. So for wheat, I think 6 months to 1 year, the production time will be there. So in this 6 months to 1 year, what will be the factors which will be affecting the yield of the wheat? So soil, then fertilizer, seed, quality of the seed, then water, so irrigation, so many things are there. So when I want to find out what is really affecting the yield, why both the plots are having different yield, what is the triggering factor, I can accurately use with data analysis, I can accurately say what is the difference, what is the reason, and the efficiency and advanced analysis. We can also visualize the data. There will be consistency and replicability. There will be flexibility and credibility. What is accuracy? When I collect the data, when I try to use a data analysis tool, error will be reduced because I am using a software. Human error will be reduced. So that is important for any accurate, for any data. So for any data, when we use some appropriate tool, errors will be minimized and the accuracy will be maximized. And for efficiency, when we try to use some specialized tool, like for cause and effect, we will use regression. There are particular tools for each and everything. When we try to use a proper tool, we will be efficiently saving our time, we'll be saving our effort. And sometimes in some tools like Python, like R programming, these we have built-in functions. So we don't have to repeat the task again and again. We can try to automate everything. So we will be more efficient, saving the time and energy. Some advanced analysis are there, which will help us to find out, even build a conceptual model to perform complex things like regression analysis, factor analysis, all these things. We can try to take the help of advanced tools, and we can try to make things better. Our research can be in a better way when we use proper advanced statistical tools. Sometimes what happens, data is there, we can do analysis, we can find out some results, but in proper place, we need to present it in a better way. We need to put proper graphs and charts, and which will be interactive. Visually, we have to communicate. We need to use that visual communication. So we need wonderful, beautiful graphs and charts and pictures and patterns. And we need to identify the outlier. So when I try to find out the outlier, it will be easy for me to communicate in a better way, to engage the stakeholders. So data visualization is equally important like data analysis. So take a stock market. In case a share of a particular company is fluctuating, so if I put it in a neat graph or trend, I can calculate to what extent it will improve and where it is, and going forward what will happen. Another example, let us take the government revenue and expenditure. So government expenditure, if I want to predict what will be the expenditure of the government in another 10 years, so I can beautifully draw it in a graph and visually represent, and I can also identify the pattern, the trend, and what is really contributing for the expenditure, what is the expenditure I have to reduce. That I can find out with proper data visualization softwares. Now, consistency and reliability. When I use a proper tool, statistical tool or an analytical tool, there will be proper consistency, and I can repeat it n number of times, because it will help the researchers or the analyst to formulate the same method and replicate the analysis, and it can validate the transparency in the research. Here, I would like to recall one of my experience wherein I worked in an industry with respect to data, which helped me in this consistency and reliability. There is a medical company here, like Central Leather Research Institute is an institute, CLRI is reputed in Chennai. So these people wanted to help the diabetic people. They wanted to design a proper shoe for the diabetic people. Usually, all the diabetic people will be having some form of problem in their foot. So ulcer, there will be some ulcerated foot. Some people will have their ulcer in the right leg. For some people, it will be in the left leg. So what happens when these people, when they walk, due to their ulcerated foot, they cannot walk in a proper way, and that movement, the flexion, the ankle movement, the knee movement, the hip movement, everything will vary. So there was a project which I had to work. It was biomechanic project. So while designing the shoe, what they tried to do is they wanted to understand to what extent they can change the manufacturing mode of the shoe. For that, they took 200 diabetic patients and they made them to walk, and the motion was captured. The pictures of the graph for the motion captured graphs were given. And with that, in that, all the 200, there were some who had left foot, some who had right foot, some were control group. Even though they were diabetic, they were not having any ulcerated foot. So it was a mix-up. So in this process, I was requested to give some 20 parameters, analyze in 20 parameters like flexion movement, knee movement, then ankle movement, hip movement. So there were deep parameters, the tendon, a lot of intricate parameters were there. So we had to analyze, we had to compare the left foot, ulcerated foot people and the right foot. And accordingly, we were requested to submit a report to CLRI. With the data, they planned to design the shoe in such a way that the shock absorbers and the landing of the shoe, when a diabetic patient is wearing the shoe, they can land in such a way that ulcerated foot will not affect them. So the design of the shoe was made from the inputs, whatever was received from the statistical analysis. It was an interesting project. So here we can replicate what happened. Initially, I had to do once ulcerated and non-ulcerated. Then I took left and right. So I had to replicate the same whole process with different type of data. And of course, we use some data extrapolation, and we try to do. And when I gave the results, it was completely transparent, because I was able to show the researchers what was really happening. So it gave a nice feel, and the output was exactly helpful for redesigning the shoe for diabetic people. Flexibility, when we use appropriate tools, the flexibility with the data diverse format, because each and every data will be unique. You take a stock market data, it will be given in a trend way. You take marketing data, again, marketing data will have different quantitative and qualitative variables. For example, there will be a lot of nominal variables as well as scale variables. We can take age, we can take educational qualification, we can consider occupation, educational qualification, gender. These are all nominal variables which cannot be measured. They can only named. So when I want to see which occupation people are buying, if I take a research of green products, so what is the purchase intention of the green products? Who is really intended to buy green products? Like that, I can try to find out lot of diverse data, marketing, microfinance, entrepreneurship, HR, everywhere. The flexibility is there. We don't have to replicate the same thing because every research project is unique and we can try to adapt a different technique everywhere. Now coming to credibility, once, as I mentioned about the CLI project, it was so credible that it was success. It was a super hit success. So when the data analysis is proper, when we use appropriate tools, the data analysis is appropriate, and hence we can easily depend on the data and we can authentically speak, and there will be a trustworthiness on the findings because the methodology is accepted properly and the statistical tools which we apply are relevant. Okay, now slowly let us understand some tools for data analysis. The interesting tools and the basic tools for statistical software is SPSS is base. It is like ABCD. So for any management, social science, humanities research, we use SPSS. Even in sometimes in English literature when we collect data, in medical science, in biomedical, bio-related biotechnology, everywhere, we use SPSS. And in some cases, we use SPSS and SAS are similar to each other. We can interchange, but for research purpose, always we use SPSS. Of course, R is an open source programming language. It helps in software environment also for statistical computing. Now moving on. Firstly, when we take the data, we don't have to use any SPSS advanced level software packages. We can take Microsoft Excel and happily we can start working on Excel itself. So we can put all the data, we can start feeding in Excel. From Excel, it is easy to import any software. And if sometimes we can also use Google Sheets so that we can share with each other. And one more competitor is LibreOffice Calc. Now moving on to the data visualization tools. There are some tools which will help us to visualize the data. As I mentioned earlier, the graph chart and all, if I want to visualize, there is a software called Tableau, Power BI, and Google Data Studio. Similarly, when we try to use a survey, when I want to collect a survey, usually in general, people use Google Forms. But sometimes we use SurveyMonkey and Qualtrics also. Of course, it has its own advantages and disadvantages. Similarly, programming languages. When I take programming languages, Python is the #1 programming language. We can do anything with Python. We have a lot of libraries like NumPy, Pandas, and SciPy. Also, MATLAB. We can use MATLAB for mathematical related things, wherein Matrix Laboratory, it is by Matrix Laboratory. We also use Stata. Stata is a statistical software. Okay, sometimes what happens, text analysis. When we try to do text analysis, we use, like, it is a qualitative. We have some texts. We don't have numbers. We have texts. Based on the text, we want to do some analysis. So the tools which is provided, like for different things, we have different functions and different manipulations, and we have different statistical analysis. Sometimes we have machine learning algorithms also. So we, as a researcher, we should know to have which tool we need on a specific objective, what are the data characteristics and the complexity. So the researchers and the data analysts, we should always think like what tool we should use when. Statistical, like, now let us go deep about each and every aspect. So statistical software packages, we have SPSS, SAS, R, and Stata. So it helps us in different ways. So each software is good in one way. SPSS is widely used in social science and business. It is usually a user-friendly interface, but still it has its own stringent norms. We will be using SPSS. We'll be learning SPSS in the next session. So it is helpful for data management, for descriptive statistics, for regression, for factor, and many more. Also, we will be using for graphing and charting. But in general, I would recommend Excel for graph and chart because SPSS graph and chart are not that attractive. That's not catchy. And also SPSS helps in data management, in explaining the descriptive statistics. Why I am giving more emphasis on regression is cause and effect. Cause of one is going to give the effect on the other. So cause and effect. And usually it is helpful in both academic and as well as business research. So SPSS is one of the credible software among the research field, in the research field. Now comes SAS. So in the popular, like in healthcare, in financial market research, we use SAS. And it has a comprehensive statistical analysis. Again, it has the data management. It has an advanced level of predictive modeling also. It also provides a programming language for manipulation and to analyze. R. So R is an open source. You can easily download. It helps in statistical computing and graph also. It also has, it is an interconnected software between statistics and IT. So computer also it helps. It offers flexibility for customizing the analysis and also to repeat the same research once again, we can use R. Data. Data is one software which is widely used in social science and economics, where R is used mostly in IT field and software and other analytical field. But in social science and economics, we use data. SPSS we use in business and academic purpose. So here this has its own set of management tools and graphic capabilities. Of course, in startup we have to give command. Always we try to give command, and we also find ways for automation. So all these statistical software packaging will suit the data analyst, and we can try to use it and interpret. One thing is each one has its own advantages and disadvantages. So we have to, as a researcher, we have to select which one is suitable for us and what is the present research, what is the need, and how to prefer. So that is up to the hand of the researcher. Now coming to the data visualization tools. So data visualization tools will help us to see the data and understand. So a picture is worth than any words. So usually some data visualization tools can be done using Tableau, Power BI, Google Data Studio, D3JS, ClickView. So Tableau, what is Tableau? It is a powerful data visualization tool. It offers a user-friendly interface. We can with a drag and drop option, and it will create interactive visualizations. It also gives a lot of chart types, maps, and other storyboards. It will help the data to present in an effective way. And it also supports data integration from various sources and advanced analytical capabilities. Power BI, it is another software. Like it is a business intelligence tool by Microsoft. It also helps the user to create interactive reports and visualizations. It also offers data exploration, data modeling, and some data preparation features. So when I have a data ready, I can try to explore what are the possibilities. I can try to build a model, and also I can try to prepare the features. It integrates well with other Microsoft products, which will be helpful in cloud-based. Whichever Microsoft product is useful in cloud-based, their Power BI will come for helping and sharing. Google Data Studio, it is a free web-based data visualization tool. Also, it helps to make some interesting dashboards and reports. And it also helps data connectors for importing the data multiple sources. And also when we try to, it provides collaboration, and it also helps sharing options which will be suitable for team projects. So usually Google is famous for sharing. So we use Google Docs, we use Google Sheets, everything we use to share to each other. One more software is called D3.js. It is basically from JavaScript, and it helps in creating custom and interactive data visualization. It is also a powerful tool for managing the documents based on data, which are having high customization. It offers a wide range of visualization. It also helps in animation and interactivity. It is a business intelligence and data visualization platform. So to create interactive dashboards and visualizations, ClickView is used. Also, it is helpful in data modeling and in memo processing for efficient analysis. It also provides options for collaboration, for sharing, and for exploring. Usually, all these data analysis visualization tools will help us to transform a complex data into simple patterns and identify some trends and some common insights in them. And each tool again has its own features and strengths. And so as a researcher, we have to choose a proper tool for the visualization requirement and for their preferences. So far we saw different type of statistical software. We saw different type of data visualization tool. In terms of statistical software, we saw SPSS, we saw SAS, then we saw SPSS, SAS, and R programming. Similarly, in the data visualization, we saw Power BI, and we saw D3JS, and we saw one more data visualization tool. So there are different types of data analysis software, different types of data visualization tool. As a researcher, we have to find out a proper place to which one we need to work and what is the need of the hour for this research. With that, we can do the research. So now, okay, now we have designed the questionnaire. We want to collect the data. So what is the next step? Once the questionnaire is ready, we have to circulate it to collect the data. We have planned our software, which is the software platform we are going to work. We have planned in what is the data visualization technique we are going to do. But without a data, how can we proceed? For that, we need data. So sometimes we use, most of the times, any researcher, it is easy to use Google Forms. So we use Google Forms. Sometimes we use SurveyMonkey also. And sometimes we use Qualtrics. These three are the high level of the survey and data collection tools. So each and every, like, how do we have data analysis tools? We have data collection tools also. In general, Google Forms is affordable because most of the, in normal Gmail, it is available. So we can use Google Forms to formulate a survey. We can just prepare a survey in a Google Forms. We can circulate the link and we can try to collect the data from our known sources. What is SurveyMonkey? It is a popular online survey software. It helps the user to create and distribute the surveys. It has a lot of multiple types of question types. Also, customer survey templates are available, and also survey logic options are available. It also provides some data analysis tools, which will be of real-time reporting with other data analysis platforms. Google Forms, as I mentioned, it is a free online survey tool, which can be available along with Google Workspace Suite. So enablers used to create custom surveys with the question types and design. We already know we would have circulated a lot of Google Forms, especially during COVID. We were circulating everything in Google Form. So it helps easy sharing, easy to collaborate, and the responses in the Google Sheet can be easily, quickly downloaded for data analysis. Qualtrics is a comprehensive survey. And again, it is a platform used by academic researchers and business. It helps in survey building features. Also, it has a lot of branching and survey logic options are available. It offers advanced data analysis capabilities. Also, it gives a lot of research tools and integration with other data software. There is one more software called Typeform, which is an online survey tool for visually appealing and user-friendly. That is the advantage. It allows the users to create engaging survey with multimedia effects. So the customer can create, the users can create on their own, on the question, on the style they want. Also, it offers real-time data visualization with powerful data analysis and reporting tools. Survey Gizmo is another flexible survey and data collections platform. Again, it is used only for market research, for feedback and employee surveys. So here, different types of questions can be there, advanced and logic, and customization options also. So it offers reporting and analytical features, including the segmentation and the trend analysis. So the data is segmented, which is similar to each other, and the trend is also analyzed using Survey Gizmo. Now, slowly coming into our picture, survey and data collection. Okay, now we have collected this, we have done the data, we have collected the data survey with the survey data collection, we have got the data. So now it will provide an options to design and administer surveys, respondents, and manage data. So once we collect the data, how do we analyze it? We will use user-friendly interfaces. We will use customizable templates, and also with our own data analysis capabilities, we make the essential for efficient data collection and for analysis. Choice which tool we want, that again depends on the budget available, on the data security, with respect to the target audience and the complexity. These are all few factors which will help us to figure out what is the data collection tool we want. Now slowly moving on to programming languages and libraries. So usually programming languages in quantitative data means it will help the researcher and analyst to which tools to manipulate and how to handle. Some common used programming languages are Python, R, and MATLAB. So Python is a dynamic and versatile programming languages. Among lot of languages, it is one of the dynamic and versatile programming language. It has a lot of libraries like NumPy, Pandas, and SciPy, and also it has a lot of numerical operations which can manipulate and do some scientific thinking also. Similarly, Matplotlib, Seaborn, and Plotly are popular library in data visualization, and Scikit-learn and TensorFlow, they also offer machine learning capabilities for predictive modeling and for data mining. Now comes R. Actually, compared to SPSS, in my opinion, R is much better because R is command based. SPSS, we don't need command, we have to run the report. So R has more logic. That is what I feel. So the basis R system functions will have manipulation of data, statistics modeling, and visualization. So when we write additionary package, we will do dplyr and tidyr, ggplot, and to enhance the data manipulation, visualization, machine learning capabilities are used. Now moving on to MATLAB. MATLAB is a programming language, and in an environment used where science and engineering alone. So only science students and engineering students will be using MATLAB, and it has a lot of functions and toolboxes for majorly for computing, for matrix operation, and for data analysis. Also, MATLAB will offer specialized toolboxes such as processing, image analysis, and optimization. Now, the different programming languages have different reasons. So, we need to find out a proper software, proper programming language, which will suit our data and which can take us forward. Now, in addition to the statistical software packages, we have some more concepts. Like when I collect the data, I cannot directly go to SPSS or Stata or SAS and do. So initially, I need to do some basics from the data cleaning, data mining. So there, Excel will be an excellent software to work. Of course, Power BI and Google Analytics also can contribute. Okay, now I am going to select the data analysis tool. What are things I should find out? First, I see a data. The data should speak to you. So as a data doctor, I would say, we should check the data. We should analyze it in a perfect way. What are the things available? Is it a nominal variable? Is it an ordinal variable? What type of variable it is? What can be the analysis I can do? What are the characteristics of the data? Whether end-to-end all the characteristics are taken? Is there any compatibility and integration? Is there a chance, scope for scalable and getting scaled up, and performance? Also, the cost and budget. We need to find out the cost and budget. And we need to find out whether we can also have, based on the community. Sometimes what happens in some software, there is no support system. There is no community to help us in case we are into trouble. So we need to select a statistical software wherein there is a good community support, and the flexibility and extensibility also is important, because in one software, if it is used and we should try to use it in another software also, it should be flexible and extendable in other softwares. And we can also for future, to what extent it will go, that also should be considered. Okay, now I collected the data. First thing, I formulated the questionnaire. I prepared a survey monkey form or a Google sheet form, Google document. I circulated, data came. How to analyze? What are the requirements for analysis? So we have to assess the specific analysis. What is pertaining to only our study? Just like that, to use any statistical tool, we cannot study. We need to see which one is really useful for us, for our aims and objectives. So whether we need a basic thing or an advanced thing or a highly advanced visualization things, so or some only specific data, or we need to manipulate, that depends on our hands. So the data characteristics, we have to understand that the nature and the characteristics of data, such as data size, structure, format, everything keeps changing. So some tools will be available that will be suitable for large, while others may excel at handling structural or unstructured area. How will I use the data tools? It should be easily usable. Anybody should be able to sit and work on it. If that is the case, then user interface is really working. Compatibility and integration. So when we see the data is compatible, then it is easy for us to scale up and go further. So compatibility and integration are two important parts inside data analysis. Scalability. So today I have a little data, tomorrow why not it become a big data? So for that, we need to scale up the data and to check the performance gap. Also, we have to evaluate how to handle large values to an efficient way, and also to perform the complex analysis in a simple way. So for that, statistical softwares will be helpful. Also, we can try to look for tools that can leverage the parallel process. Everywhere, if we are doing the same process, we can use some tools that can leverage, and computing for scalability, because it is a matter of concern. Cost and budget. If I want to buy a software, I have to see whether it is really affordable, whether the cost is fine for that thing. If a subscription, whether its subscription will really go waste, like that, we have to see based on the training, based on the support, and based on the upgrades, we can work. Also, when we try to consider the budget constraints and the weight against the expected benefits and the values to the tools. As I mentioned earlier, we need a community everywhere. So in the online forums, we need some support system for tutorials or also some documentation. Sometimes with YouTube videos, we learn. So we need a proper some community and support system, then only we'll be able to work. So we have to have an vibrant community, which will help us to assist and also share the address and share and help us to address to any issue or challenge. So we need a proper setup to address to the issue. When I try to find out what is the reason of flexibility and extensibility, so when the customer is, when I get a data from a customer, I can use it in additional libraries, or I can pause, or I can try to incorporate scripting, so or some other language. So it will be helpful in flexibility and extensibility. So usually when we try to collect the data, we can consider the selected accommodated for the future requirements and for expansion or the adoption of more analytical techniques. So concluding the first part, the data analysis is easier. A lot of techniques and tools, lot of softwares are there. So when we try to consider the analysis requirements, what is the data required? We can try to find out the dependent variables and independent variables. The choose and whatever tools we are using, like independent sample t-test or ANOVA or pair t-test, which is really appropriate for that data. There we try to choose the tool, and with a specific analysis, we can try to do some research, some data visualization, and some data integration also can be done. Of course, data manipulation also will be done. So the selection process always should not be a lengthy time, because the future and it should be helpful for the future analysis, and it should need the potential for the expansion of the techniques. So I wanted to finish the introduction part because it is only theoretical. I wanted more time for SPSS, so that if scholars are having SPSS in your laptop, you can also run parallelly and learn. So if you are having any difficulty in installing SPSS, you can let me know. We have some 5-10 minutes. That is the reason I wanted to finish the theory part early so that we can take more time interacting in the data analysis part. So if you are not installed SPSS, through the link which ma'am has shared, you can try to install. If you have any problem, you can tell me. We have some 5 to 10 minutes. We can try to sort out so that when I run the program here, you can also do it parallelly in your place to learn more. Oh, if you have not received any problem, you can raise your hand. If you have a problem, you can let us know. We can try to help you here. Somebody is requesting for any help, I'll try to give some more inputs. So for quantitative data tool, first thing we need is data. How do I get the data? I need to collect the data. Okay. How do I collect the data? Either SurveyMonkey or Google Forms or Qualtrics use some online platform to create a survey and just post it in your known sources to collect the data. Okay. Now with great difficulty, we have collected the data. So what do I do with the data? I can easily download it in form of Excel. So with the Excel data sheet, what can I do? I have to use appropriate tools to analyze and to find out proper inference. So dear participants, if you have any problem in the installing of SPSS, please let me know. I can help you now. We can slowly move on to the next session. Maybe we have 10 minutes time. So please let me know if you want any help in installing the SPSS. You can also share your screen and we can try to help you in case you are getting trouble.
Ma'am, some participants are facing problem in downloading the SPSS.
Yeah, I have shared a link yesterday. If you download, that is a WeTransfer link.
They are facing a problem during the installation of the Python. It is mandatory to install the Python?
No, we don't need Python. We don't need Java. Like just like that. Yes, if any of the participants is like they want to install, they can share their screen. I can also help them so others can see and learn. If any of you have not installed screen,
you are facing a lot of problems. Just share your screen. Share your screen.
I can help you people. If one person can do that, everybody, it will be easy for everyone. I can stop sharing my screen here.
Okay. So you actually one of the student is facing problem and she's joined with mobile phone. Just join by using your laptop, no? Anyone else who has faced problem during the installation? He or she can share their screen, so ma'am can guide.
Please share, I can help you.
Yes.
The next session is going to be interactive. It will not be theory. We can work parallelly. If you have your SPSS in your laptop, we can work parallelly.
It's a hand-on training program.
Yeah, it's a hands-on training.
Session 2 is a hand-on training program. Please join using your laptop. If you are using your mobile phone, then please keep your laptop beside you. So then you can do practice with Padmaja ma'am.
We can learn together.
Yes, ma'am.
Dear participants, need your vibrant participation. Then only it will be like hands-on training. Anybody who has problem in installing, you can tell us. We'll be able to help you to install. We have 5 minutes time, we can install. Anybody wants the help? Or all of you are having SPSS? A new message. Downloading. Somebody is downloading SPSS. If you have a problem, you can tell us.
Jima.
Mr. Kumar Anup has sent a message that he is downloading. Kumar sir, we are waiting for you. If you are not able to download it easily or if you are getting any problem, you can tell us. Perfectly done. Wow. Nice. Anybody else? Download done. Sarita Sharma. Nice. So you all are having SPSS now. I presume that you all are having SPSS. Because when we work, you can also work. It is giving options for using Unicode or local encoding. Which one should we select? Unicode. If you have your laptop with SPSS, it will be interesting for you also to parallelly work.
Sarita madam, can you share your screen? I think you have downloaded your SPSS, right? Anup sir, can you share your screen so that other participants can also see your screen?
Ma'am, I have downloaded on my laptop now.
Yes.
Okay, it is a temporary version. Can you go to the SPSS? This is an output file. Can you go to the input file? SAV file. This is SPV file.
Temporary version. Ma'am, I have provided as temporary version or
I had shared a link license. If you had put the license, it will become permanent. Yeah, this is the SPSS file. Perfect.
Okay.
This is the input file. So I assume that everybody has SPSS. So similarly, I will share Amos also like this, ma'am, link in a link form. People can install so that it will be helpful for the next sessions.
Right, ma'am.
Yes, sir.
Without
Yes,
software, they cannot learn. No? For downloading is needed in case of hand-on training.
Downloading is any message? Yes, I think we can move on.
Yes, ma'am.
We can move on to the next session. Quantitative, let me share my screen. So this quantitative analysis using SPSS. So many of us have been learning SPSS, we know, but still always it gives interest to learn, especially for management, for social science, and for humanities background. SPSS is required for any, even for writing a small article, we collect the data. When we try to put in the, I have seen many journals using only SPSS. The journal, the author of the article has used SPSS. Okay, now a small introduction. We have numbers everywhere. Like we can say easily, we can say 90% of the country have television. So we have statistics is dealing with numbers, and we have numbers everywhere. Data is there everywhere surrounding us. So it is omnipresent. For simple example, we have data in cooking. Like we know, our mother will know inventory, in what level, into how many days the oil will get exhausted. She is a better inventory manager, and everything we know how much to buy. So we know to predict. So shopping, when we go for shopping also, we have a budget, we go and we buy, we have a data. In sports, cricket, take an example of cricket, the striking rate, the batting rate, average. So we deal with data everywhere. Okay, but there is a problem in data. Usually data is not normal. Okay, what do we mean by normal? How can a data behave normal or abnormal? So it looks so weird to say. The meaning is there is a protocol. If there is a data, then it should follow a data pattern. So if it follows a particular pattern, it is called normally distributed. Then only if the data is normal only, we can proceed with any statistical tool. So how do I define a normal data? A simple example, I can say 2 or 3 different scenarios. Let me take a first example. Let us take the sales of gold in a jewelry shop. In one particular jewelry shop, one particular branch, if I want to take the entire day's sales, I can see sales of gold. I can see very few would have, there will be outliers very minimum. That is only 1 or 2 would have bought an abnormal rate of gold, amount of gold. 1 or 2 would have come and purchased in a great extent of 10 lakhs or 20 lakhs amount worth gold. And similarly, very few, 1 or 2 or 3 would have come just to purchase a simple 10,000 rupees worth, a small gold coin. But in general, in one particular day sales, if I take the trend and see, most of the people would have purchased somewhere between 1 lakh to 2 lakh based on today's gold rate. So when I try to plot the graph, so if I take the x-axis as the sales of gold, and y-axis the number of people. So what will happen is the outliers will be less. Most sales will be very 1 or 2, and least sales amount will be 1 or 2, and the middle sales will be more. So when I try to plot the pattern, it will beautifully come into a form of a bell curve. So that is one example. Okay, now take the students. We all are researchers and most of us are teachers also. So in our class, what happens? Students are there and the marks. When we conduct an exam, obviously we get the results. So when we see outperforming, number one outstanding students will be 1 or 2 who have scored 100 or 99. Similarly, the least performing students will be 1 or 2 who would have scored 4 single digit mark. And most of the students will be revolving in the center, median, mean, like 60, 70, 80. So again, if I take a graph wherein x-axis is the marks, y-axis number of students, I can see the marks, more marks, 100 marks, 1 or 2 will be there. Again, 0 marks, 1 or 2 will be there. 60, 70, 80 will be the middle. And when I try to plot a graph, it will show in a bell curve. So this is what data, any data will behave normal, means most of the data will be revolving in the center across the mean. It will be near the mean only, and the outliers will be very less. There can't be more outliers. So the data will be perfect. It will not be skewed. It will be symmetric. So there is like, if you want to, usually given a data, before even entering into SPSS, you should see whether the data is normal or not. How to see normal? A simple thing. Take the data, put it in Excel, draw a histogram. If the histogram, we don't have to be perfect histogram. If the histogram is showing a little bell curve, then the data is normal. We can proceed. If we are not able to see the histogram in a normal way, in a bell curve, then data is not clear. So we need to adjust the data to make it normal. So normality is one important thing in statistics. So even before entering into SPSS, I thought I should emphasize with the concept of normality. The number one assumption in SPS, in any data analysis is normal. Data is normally distributed. So we have to assess whether the data is normal. Of course, SPSS has some methods of assessing the normality. For my data analysis, if I am doing any data analysis for any PhD research, first thing I will do is I'll check the normality and I'll plot the histogram and give. Once the normality condition is complained only, we can go with further data analysis. So the way do we use SPSS? One is to manage the data, second to analyze the data. So how do we manage the data? Just to handle the data, first define the variables, code the variables, code the values, enter and edit the data, create new variables and recoding and selecting the cases. These are all like first fixing the data in SPSS is called data management. Then comes data analysis, wherein we have univariate, that is only age, only height, only weight. When we try to see this data analysis, by univariate, bivariate, when we have two variables together. Let us take an interesting example of whether I want to identify the vaccination is really effective in one particular place with respect to COVID. So whether the COVID-19 vaccination has been effective or not. For that, how do we check? We go to a place, we go to that particular place and we check how many of them are vaccinated and how many of them are infected. Even after vaccination, like have they vaccinated or not? Have they been infected or not? So we can try to put a 2x2 contingency table. Vaccinated, not vaccinated, infected, not infected. So when I try to cross tabulate, what happens? Those who are vaccinated, but in spite of vaccination, infection is there. Those who are vaccinated and infection is not there. There is no COVID infection after vaccination. One more thing is not vaccinated. Those who are not vaccinated, but they have got infection. Not vaccinated, not infected. So it is a beautiful 2x2 contingency. This is a bivariate. There are two variables, vaccination and infection. Similarly, we can have multivariate analysis wherein we have more number of data. As I mentioned the example earlier, agricultural yield. The production of any agricultural produce will depend on multiple independent variables. Soil, then fertilizer, then seed, then rainfall. So multiple variables, of course, which are not dependent on each other. Soil is not dependent on the seed. Seed is not dependent on the fertilizer. So we don't have to really, there can be dependency, but there can be independency also. So that is, if there is a dependency, then we will go with covariance. So that is multivariate analysis. Okay, now how to open SPSS from the beginning. So either you go to the desktop, and if there is a SPSS, you just go and click. Otherwise, go to start button, go to programs, go to SPSS and open. So that will follow the introductory screen. So this is the basic pathway to open an SPSS file. So this way we will SPSS for Windows, it will open and we can easily open the file. This is as one of our sir showed, data view. So this is a data view. There are two views you can see. You can go to your SPSS, open your SPSS parallelly and see. There will be two views, data view and variable view. What is data view? Data is to enter the data, but even before entering the data, we need to give variables. We need to specify the variables, make the SPSS understand. Now let me show a demo for that. Let me take an SPSS file. Let me open a new. I think you also have the same SPSS file. If you have not got, please open. If you have any doubt, you can in between, you can raise your hands so that we can solve the doubt, or you can also use the chat. I'll keep following the chat box also. So variable view, data view. Now let us imagine the first example what I told. We are conducting a marketing research about a toothpaste. So we go and ask questions. There is a questionnaire. We keep collecting the data. So once the data is collected, we have to enter it. So first question we would have asked is gender. So gender, we are creating the variable. We are making the SPSS understand. So we are creating the variable, gender. Usually we don't like decimal. Gender is a nominal variable. It is a naming variable. So we keep gender as decimal 0 and we need to give values. We can't use gender like that. So we try to give value labels. In general, we give 1 for male, 2 for female. Okay, I repeat. We give a new variable. We are going to make the SPSS understand our data. So we go to the variable view. We start creating the variable gender. It is a numeric type because we are even though it is male and female, we are going to give some code for that. So we make it as numeric because with string variable, we can't do further statistical operations. So we convert it into numeric and we make the decimal 0. We give 1 for male and 2 for female. If required, we can also give label gender of the respondents. Now moving to the next one, age. So we do all the basic demographic things what we have collected. Here we give age of the, it will come in the output. For that labeling is to get in the output. One is less than, our survey is to cater to all the needs of all the age groups. So less than 18 years. To maybe 19 to 18 to 30. 31 to 45. We can, it's our wish. We can make in any way we want. Or else you can even change. One is less than 15, so that there will be some uniformity. Frequent, the distribution will be uniform. 16. 4. 45 to 16. 5. Up to 60 years. So far, we have learned how to enter a variable. If you are able to work with me, it will be nice. You can also unmute yourself and you can tell if you are able to work with me.
Yes, ma'am.
So far, so good. Can we proceed?
Yes, ma'am.
Thank you. Thanks for your response. It gives more energy. Now, age, gender, what can be for a toothpaste? I want to do some toothpaste survey. So what can be the next variable? I can take brand name. What is the current brand you are using? So brand.
Sorry, ma'am, can I interrupt?
Yeah, yes, please.
Why we have put gender in a numeric type if it's a qualitative data?
Pardon me?
Why we have put gender in a numeric type?
Numeric, that's what, because if you put it in string, you can make it one male and female without giving any coding, you can string, but you cannot make it into take for further statistical analysis. You can just have a graph and a table. But if you want to see whether gender is really affecting a set of people, a set of responses, perception, then you need it in numeric. If you make it string, it cannot be taken for further statistical analysis. That is why we change it as an, even though it is a nominal variable, we try to make it in a numeric way so that we can go for further statistical analysis like independent sample t-test. I will show you how do we do that. That was a nice question to ask. So that is why we gave coding 1 as male and 2 as female. So we are making the computer understand whenever I give 1, take it as male. Whenever I give 2, take it as female. Similarly, age, problem with age, if we have, age is a numeric variable only. But if I put 15, 20, like whatever age I give, the original age, I cannot take it for further statistical analysis will be not conducive. So I want to make it as a segmentation, some intervals. If I give some intervals, it will be easy for me to handle further. Let me show maybe this variable, let me have it as age range because I have given range. Let me have one more variable as age, numeric and age. We can also ask the same question here. Why can't I handle the age as it is? We can have age. Here we will leave it as it is. Now coming to brand, we'll also move this brand. Brand is, I try to give, maybe first one brand is Colgate. I give one as Colgate. Second brand, famous brand is Babur. Third famous brand is Close Up. What else? Fourth one, Pepsodent. Fifth one, any other, maybe for ease purpose, any other brand. Now this is there. Now I want to maybe perception. We will take few more variable parameters with respect to perception. Taste. To what extent you are using, you prefer this brand with regard to taste. Taste. So I will give Likert scaling here. One is strongly disagree. 2 is disagree. 3 is neutral. 4 agree. 5 strongly agree. If you are able to work with me, it will be easy for you to understand. Taste. Then we can, what else can be the parameters? Texture, color, quantity. Some people will prefer less quantity, quality, price. These all can be different factors. I don't want decimal. So some people prefer the thing for texture. Some children will like the colors. Some people will buy in huge quantities. Some people will buy in less quantities for the price. Now everything is same Likert scale. So I begin. Please let me know if I have to repeat this. If you are able to follow with me, it will be nice. I can also wait. We can wait for you people so that you can also prepare till this. Because it's an hands-on training, it will be nice if you work together. Can we proceed or can I wait?
Kindly update your status by showing any indication, either by reaction or by your own, so
In
that
chat also you can put. In
yeah, it
chat
will be
message
helpful
also.
for her, so that we can proceed. If we have to wait for a while, or we have to proceed. At least,
Ma'am, what
your reaction.
Yes,
what
ma'am.
what does missing field indicate after the values?
Missing.
Yeah, when we see those,
We don't have to worry about missing at this moment. When
Okay.
one or two data are missing, we can give those values there.
no, what does that mean? Suppose I filled its gender wala row,
Uh,
numeric in all values, male, female, and third being transgender, for example. Then the next field is values. So,
Okay.
what exactly does it mean? Not in gender variable, but otherwise.
Otherwise,
Theoretically, what does it mean,
values.
ma'am?
So we
Yes,
are
ma'am.
trying to values. We are trying to make
Not the values, ma'am. The missing field.
missing. When we enter the data, there might be one or two data missing. For that purpose, if we don't want to, anyway, we are going to give. So we are going to tell which data is missing. So this usually we will not use because we will make the data complete. We will clean the data and enter. We will not worry about that.
Okay, ma'am.
Now going to the data. Usually we will see the data input, but here for practical purpose, we will fill by on our own. Usually we would have collected the data from Google respondents, Google Sheets. Randomly we can put gender, we gave 1 and 2. Age range we gave 1, 2, 3, up to 4 we gave. SPSS is one dumb software. It will accept everything, whatever you give. It will not say, no, you gave me wrong information. So we should be shrewd enough to understand whether what we are doing is right or not. So age range we gave. Brand. Brand is 3, 4, 5 brands we gave. For you can also view the value label so that you can understand what is that you gave, whether it is coming. So whenever we have a Google form, from the Google form, we can directly copy and paste the data in the data view. Now the age, this is range, this is proper age. For me to explain, I'm putting both. So less than 15 means it can be 13, 16 to 18, 31 to 30, 33, 19, 12. So I'm just taking this column and based on this column, I'm trying to fill 25, 27, 39, 19. If it's a bit fast, you can tell me, I can slow down. So we have filled here, it's all Likert scale. 1, 2, 3, 4, 5. This is each and every individual's details we are filling from the Google Sheet. Usually it is like Google Sheet. Now to have a practice of SPSS, we are doing it on our own. But as a researcher, we are not supposed to do on our own. We have to take the respondent's response and only we are supposed to do. In statistics, 30 is a decent number. That's why I want to fix with 30 here. Now for time purpose, I try to copy and paste. So everything is in place. Please let me know, are you traveling together? Are we all traveling together? Or can I proceed? Participants are busy entering, that means.
You just update your status. You don't have to fill all the entries. At least for an example, you just enter up to 10
or two.
entries or 1 or 2 you can
Two
do, so
columns
that
and
you
rows.
will understand and how it will work. The process you have to understand. So don't wait for the we have to put the entries of 50 to 60 numbers and all that. Just put 5 to 6 entries and then we will proceed further.
Now I will show, we will go to analyze, we will go to descriptive statistics. First thing is always percentage analysis in any data analysis. First thing is what is the percentage of the population. So we will take all the demographic factors and we will do the basic. I have selected only the demographic factors and I have presented. Now I have the output. Gender, 20 male and 10 females are in the participation. Age, so it has given a beautiful output immediately. Age, less than 15, 4 people. 16 to 30, 11 people. 31 to 45, 11 people. The current brand. So current brand, Colgate, 2 people prefer Colgate. 11 people prefer Dabur. 8 people prefer Close-Up. 7 people prefer Pepsodent and 2 people prefer any other brand. Now see, this is the reason I wanted to make age in a range. Now from 10 to 49, the age, all the 30 samples are given like this. So it's difficult to handle in a further way. That is why we wanted to comprise everything and put it in a nutshell. That is the reason we made age as a range. We gave range so that it is given in a beautiful table. Otherwise, okay, if it is, because it is 30 numbers, it is like this. If it is 100 or 200 or 800, it will run to pages and pages. So to stop that, we always try to make age in form of some ranges so that it will be easy to handle and in a better way. We can say 36.7% or majority or between 16 to 30 and 31 to 45 of our study. It is easy to present. So again, I repeat, how did I do this? I'll close the output and show it.
Ma'am, please explain. Ma'am, please explain about cumulative percentage.
Yeah, I'll explain. Analyze, descriptive, frequency. So if it is reset, I will take only the demographic part, not the Likert scale, the study variables. And okay. So first table we will ignore. It is showing there is no missing data. Ma'am had asked about missing. Usually, as a researcher, we will clean the data and we will ensure that there is no missing. So we don't have to bother about that missing table there. Now coming to the gender. So this 66 people, 66.7% of the study is male and 33.3 is female. Now if I take the cumulative, the total is 100, 66 is male and total is 100. Now if we take the second table, we can understand here. So 15.3% has less than 15. But when I take up 50% of the whole population is less than 30 years only. Now coming to 31 so up 45 years, from 0 to 45, I have 86.7%. And the whole data is 100. The whole set of data is divided into till 30 or 50 people. Like it is cumulative, like how we call a cumulative deposit. The value, the interest gets adding on like that. 15.3 plus 36.7 gets added to 50. 50 plus the 36.7 goes to 86.7. Again, 86.7 plus the next one, 13.3 becomes 100. So that is why it is getting accumulated. That is why we call it as a cumulative percentage. I hope it is clear.
Yes, ma'am.
Now, for a brand, we got age. This is the reason we don't want age, but only when the data is like this, we can calculate descriptive. We can have mean for any statistical thing. The next advanced level, the first level is percentage analysis. Second one is descriptive statistics. For this, you just imagine the age range and age. When we take, we don't want minimum and maximum. When we take mean and standard deviation, we can see for the age, it is 28.47. 28.47 is the average age. But when we take the range, the mean is calculated 2.5. Why it is taking 2.5? Reason is, if you go and see the range, it is one, we have given the code 1, 2, 3, 4. So it is not understanding the real age. It is taking us 2.5, which is between 1, 2, 3, 4. That median, that mean is not correct. That is why we need a proper age, the range, the full values for calculating mean and standard deviation. We cannot take the age mean like this because we have classified it. We have given a code. It is calculating the mean for the coded values. So that is why we cannot take that. Now coming to, you asked me why you didn't take gender as string. Let me show the example. In our example itself, one more column we will take gender in terms of string, gender _1. Let us consider it as string variable because it is male and female only. And let us try to copy this. Let me see whether it is copying. Yes, the same thing we have taken in terms of string. It is not numerical mail. Let me change string. I think it got changed when I pasted. So it is not taking. So let me put male, female. That is for benefit of time, just copy and paste. To show why we are not able to perform further statistical analysis. So this is string. We will remove. Again, it is getting changed. Let us try to copy. Now I can show you why we can't use this. Let us always, it is better to save the data. Save data demo. View, it is always better to see numbers. It will be helpful for us whether it is string or not. Now I want to see which gender is interested in what taste or which gender is buying which brand. So I can go to analyze and go to descriptive. I can make a cross tabulation between gender and brand. And I want a chi-square. I can see whether the data is really effective or not. So I can see gender of the respondents, male, female, Colgate, Dabur, close-up. So which gender is having? I have an assumption that gender is not influencing the brand. All the gender are having equal brand. So in such case, I try to understand all the gender is having equal brand. I want to see really it is whether it is correct or not. So when I try to go further, my chi-square always in SPSS, SIG is a value where you can see SIG is a number which will help you to find out that is the p-value. Significance is the p-value. So here 0.875. The mantra is P less than 0.05, reject null hypothesis. So here my null hypothesis is gender has no influence on the brand. So when I say gender does not influence the brand, then here P value is more than 0.05. We have to reject null hypothesis when it is less than 0.05. And as a researcher, my intention should be to reject the null hypothesis. Then only I can have some findings. So here gender has no influence because P value is more than 0.05. Now, if we try to, for chi-square, because it is a categorical, if we try to run the same thing with the normal gender, which one we did? Also string variable, that also will work the same way. That also will work the same way. See, there is a difference. But when we try to go to the next level, when I want to see with the independent, when I go, the next level of statistic is analysis is independent sample t-test. I want to know whether, and here you can see the gender is there, but you can't use it. It will be difficult because we don't have code. We can't use this. So instead, we will use this gender. We have code 1 and 2. Continue, texture, color, quantity, all the study variables, taste. We try to use independent sample t-test. As I mentioned, always SIG be our matter of interest. SIG here, because the data is less, sample size is 30 and data we entered, it is not showing in a proper way. All the significant values are more. So I repeat, how did I do independent sample t-test? Analyze, compare means, independent sample t-test, reset, go to the gender, define the groups 1 and 2, and take taste, texture, color, quantity. And run the report. I think you can try once. I can wait. In the meantime, I'll charge my laptop. Ready? So, independent sample t-test is used to find out when there are only two variables, when there are only two subcategories, here male and female. When there are only two subcategories, to find out the variation, we use independent sample t-test. Now, what happens for age and all? Age, occupation, which has more than two things. So when I take age, I'll take it as a factor, underlying factor, taste, texture, color, quantity. I can use one-way ANOVA. Again, I repeat, if the subvariables are more than two, in our case, age, we had 4 factors, 4 different categories. In such case, we go with one-way ANOVA, analyze, compare means, one-way ANOVA, age, taste, texture, quantity, whatever factors you want. So this is the output. Again, always our view should be in SIG, significant value, SIG. So this is how we do. Here the hypothesis will be gender and age has no influence on the different perceptions of the individuals. And we can try to run the ANOVA. So first we will do percentage analysis. Second, we will do descriptive statistics wherein we will see mean and standard deviation. Third, we will do independent sample t-test. Fourth, we will do ANOVA. These are all the basic statistical analysis for any data. Is there should I repeat anything once again? I'm just checking whether is there any chat message to reply. So can we proceed or should I repeat once again?
Ma'am, these tables that we have generated,
Ah.
how this inference should be made from this table, ma'am?
Yeah, how to write the interpretation. That's a
Yes,
valid.
ma'am.
What I will do as a researcher, first thing is I will copy this table and then I will open a Word document and I will first paste this table and I want it in a better way. So I will first make it in a proper box. Now my idea is my null hypothesis. So age of the respondents do not influence the perception with regard to taste, texture, color, and quantity of the whatever here it is toothpaste of the toothpaste the consumers are using. So this is my null hypothesis. Usually in any article or in any research thesis, we don't write the alternate hypothesis. Only in the book, we will write null hypothesis and alternate hypothesis. So in a data analysis part, we write the null hypothesis. We go to the statistical tool used. This one-way ANOVA. Then I give the table number. Table number 1. After that, assuming because we entered the data by ourselves, data is not supporting, the outputs are not supporting. Assuming the data is, the significant value is like this. Usually it will be like this if the data is collected. Because we only entered, if the data is not showing the proper thing. Now we see p-value is less than 0.05 in 3 cases. In 1 case, it is not there. P-value is less than 0.05. Usually P is small p and italics, that is their notation. P-value is less than 0.05 in terms of or with respect to, with regard to texture, color, and quantity. Hence,
Ma'am, what does P stand for?
probability value. That is this SIG is the p value. In general, in any SPSS table, we should always search for SIG, that is the p value. So p value is less than 0.05 with regard to texture, color, and quantity. This null hypothesis is rejected in these factors, or with regard to these factors, with reference to these factors. However, p value is greater than 0.05 in terms of with respect to taste. Hence, null hypothesis is accepted in the for the factor taste. Now my inference. Age has influence on the factors such as texture, color, and quantity. That is, the color, the quantity, and all. Small children are particular about different color, different texture, whereas middle-aged people are having different perception. So age has influence on the factors such as texture, color, and quantity of the consumers. However, there is no influence, or else we can be to repeat the redundancy, we can say impact of age on the taste of the toothpaste. This is this is how, after running an SPSS, I will try to do the interpretation part and make it in my article or in my thesis. Similarly, if I for that independent sample t-test also, this will be the style of writing. I hope it is clear.
Yes, very much, ma'am.
So this is how we write a presentation, interpretation of anything. Similarly, if I take the SPSS output of this independent sample t-test also, I don't have to take this small table, only this big table we can take. We can paste it. Similarly, null hypothesis, gender has no whatever, we can copy. Gender of the respondents do not influence. Statistical tool used, independent sample t-test, and we can copy the table. This table we can copy. In case if in this data all the p-value is more than 0.05, let me try to fit in the table to fit to window. So all the SIG value, SIG is the p-value, all the values are more than 0.05. So since p-value is greater than 0.05, null hypothesis is accepted. So inference, we just take the null hypothesis as it is. So no worries. Standard as this is how we do a t-test. I hope it's clear. It was a nice question to ask, how do I write the interpretation? There are two things. One is handling the data. Second is presenting the data in a better way in our research. So it is equally important to write the interpretation part in a preferable way. So we need to learn, we can refer nice journals in what way they have presented, and that otherwise there is one website called Statistics Laird, L-A-E-R-D. I can post it in the in the chat box. Statistics Laerd. So this is a website. This website also we can go and learn. Everything will be explained with for SPSS. With the screenshot, it will be explaining. So we can try to understand the concept, and we can try to customize the same thing with there will be beautiful examples. We can try to adapt that example to our real research problem, and we can work. Now, can I move to the next thing called exploratory factor analysis?
Ma'am, you said if dependent variable has one or two segments, then you can apply independent t-test. Or if more than two, then you would apply ANOVA.
ANOVA, exactly. Perfect. You're like on the sync. Like for only subvariables, if I same thing, in case if I am not able to, if I have the gender as male, female, and prefer not to say, independent sample t-test will not be applicable for me. I have to go with ANOVA. Same thing. Gender, if I have 3 cases, if I have one more column as gender not to say, gender not, prefer not to say gender, then it will become three categories. So if there are more than 2 categories, t-test will not be applicable. We have to extend to one-way ANOVA. If there are only 2 categories, marital status, if it is married and single, we can use t-test. Marital status, if it has more than 2 variables, in case married, unmarried, single, something, if divorcee, widow, if there are 3-4 categories, we can't use independent sample t-test. We have to opt for one-way ANOVA. Hope the doubt is clear.
So is this only difference between ANOVA and
exactly. This is the only t-test is a smaller version of ANOVA. ANOVA is the extended version of t-test. Both handle, of course, in theoretical perspective, we would have learned that about the variance. If F-test will take care of the variance and t-test will take care of the mean. That we would have read in the theoretical part. But when we take it practically, for less than 2 subcategories, we use independent sample t-test. For more than 2 subcategories, we go with one-way ANOVA.
Got you, ma'am. Thank you.
Thank you. Now, slowly moving on to the next thing is exploratory factor analysis. So let me try to share one ready-made SPSS file I have. Even before explaining factor analysis example, even before going into the data in depth, I have to explain the data first. There is a scenario of microfinance. Not everybody is getting a microfinance loan. So the main problem with people in a rural area, they cannot go to a bank and approach for a loan. Of course, without funding, they cannot proceed with their agricultural formalities or whatever little poultry or something they are doing. For that, they need a small loan. For that, bankers are not ready to give loan because they don't have proper balance sheet. For getting a loan in a bank, we need to be authentic. We need to have IT returns and all. So we go with microfinance. All these small people, microfinance people will target them, of course, for a higher rate of interest. So, but the microfinance people are so cautious that their money should come back. So what they do is they not only offer loan, they offer credit plus services. So they offer training. They also maintain the operations. They go with the skills. They also find out whether one party's input aggregation is the other party's output. Sometimes what happens, one guy's output will be useful. It will be a raw material for the other guy. So one guy's output will be the input for the other guy. So input aggregation and output aggregation. They also do market linkage. They also give advisory, like whether they have to go for crop insurance or poultry insurance, to what extent they can insure. So also there is one more factor called economic benefit. When the microfinance beneficiary is utilizing all these credit plus services, he will be getting an economic benefit. He'll make a profit, and with that he will make a social benefit. So this, and there is a livelihood. They get an income. So microfinance is giving loan. On top of it, it is offering training. It is taking care of the operation. It is giving a market linkage. It is giving advisors. It is also taking care of the aggregation, input and output. And all these things, they get an income. With all this support, a small individual, a poor guy in a rural area, he is able to make some income, livelihood. He gets a livelihood. With that livelihood, he derives an economic benefit, and that also becomes a social benefit. So this is their model, conceptual model. So if I have to run a factor analysis, the main purpose of factor analysis is you assume in the classroom, in the college first year, what will happen the first day itself, the boys and the girls who are all of same wavelength, even without their knowledge, they'll go and get connected within among themselves. They'll become a group. Automatically, they'll form a cluster. Same thing happens in data also. The variables will form a cluster which are like-minded, which are correlated to each other. They becomes a cluster. So here we have different 3 statements in training, 5 statements in operation, 4 statements in skill, and so on. Now I try to do a factor analysis. I want to see how many factors can I make. So I go to dimension reduction. I go to factor. I take all the variables and I put, select all, control A and put here. I go to descriptive. I want to know whether the factor analysis can be run or not. There is a test for that, KMO. So I go that. I go to extraction and I want a scree plot. It is called a scree plot. Then we go to rotation. Always it is varimax rotation. And for regression, I can go with scores and options. I want to sort it. I want to sort the factors. All these variables will become as factors. Usually the thumb rule is 0.6. I want to suppress the lesser values. I continue. Once again, I repeat what I do. Analyze, dimension reduction, factor, select all the study variables alone, descriptive, KMO, continue, extraction, scree plot, continue, rotation, varimax, continue, option, sort by size, suppress, 0.6, continue, okay. Now you can see SIG value, P value is less than 0.05. So it is accepted. So this test can be proceeded. I can see there are 10 factors. So the whole set of 39 variables became into 10 factors, contributing to 68% cumulative. Their participation is 68%. And you can see the curve gets flattened at the 10th factor. So these 39 individual variables are becoming into 10 factors. That is the group. They are all forming a group, like how the studious boys and girls will become a group in the first day itself, even without their knowledge. The notorious, like that, the training, the individual, all the factors pertaining to each one will become one group. You can see the rotate. This is the beautiful thing. All the operations get in one place. All the economic benefit variables statements are sitting in the second place. All the social benefit is sitting in the third place. Advisory is going for the fourth place.
Ma'am, please, you are muted.
Suddenly I've gone on mute. I didn't realize.
Okay.
So slowly we have learned all these variables have gone, all these parameters have gone, got distributed equally. So all the good category operations have become in one factor. The other, these 39 variables have got into 10 factors. So this is called exploratory factor analysis. We are exploring, there are 39 statements wherein we are trying to segregate everything into factors which have commonalities among themselves. So this is the basics of factor analysis. So we have learned the basics of how to create data, how to enter the data, how to create variable, then how to do percentage analysis, then how to do descriptive statistics, mean and standard deviation. Then we learned independent sample t-test, ANOVA, how to write the interpretation. Then we learned exploratory factor analysis. Once we do exploratory factor analysis, we can go to confirmatory factor analysis in AMOS to build, we can build a model and we can prove the model. So I think with this, with the heat is getting more here. So we are like trying to learn more in statistics. So with this, we can stop today's session, can continue again. I thank the organizers once again for the opportunity, and I thank the participants for being so vibrant and dynamic and getting along. It's not easy in an online session to work together. So I really feel that it's a nice platform here to get connected with you all. Ma'am, can we close the session?
Yes, ma'am.
Participants, if you have any doubt, you are welcome.
Yes. If you are having any problem, and please raise your question here. You
Or else you can
unmute
note down also. Again, we'll connect. We have one more session in the near 1 or 2 days, so we can again connect. That time also you can ask.
Yes, yes.
Ma'am, I do have.
Yes, please.
Yes, please.
Hello.
Please keep your video
Ma'am,
on.
you said if ma'am, you
Okay.
said hello.
Yes, sir.
Ma'am, can I say hello?
You can share.
Ma'am,
Hello.
can I ask question?
Yeah, please.
Ma'am, you told if p value is less than 0.05, then null hypothesis will be not rejected.
Reject. P less than
Okay.
0.05, reject H naught.
Okay, it will reject it. But what way if p is equal to 0.05?
P equal to 0.05. Usually we will P, even if it is 0.05, we can reject. If it is more than 0.05, we can accept. P less than or equal to, if you want, I can modify. P less than or equal to 0.05, reject.
Okay.
Thank you.
Ma'am, I have one query.
Yes,
During
ma'am.
regression analysis in MLR, if we find out the R square value greater than 7, so usually software says it is not good fit model. So what is the criteria for publish the paper in a good research journal?
R square value, there is a concept like R square, adjusted R square. There are two things. So we should take a call based on the R value, R square value, and the adjusted R square value. So we decide on the adjusted R square is more important than R square.
Yeah, but what is the criteria to accept in a good journal? Because sometimes it says that 0.7 is a good. In some papers, I read that more than 0.7.
So adjusted R square value should be between 0.5 and 0.9. So that 0.9, that is usually in social science research, adjusted R square value is between 0.5 and 0.9. So that is acceptable.
This paper?
Is it okay, ma'am?
Yes. Is any other participants, you have any query regarding the SPSS in downloading? If you have faced problem, you can share your screen so that ma'am can solve your problem. Yes, anyone?
Good afternoon, ma'am. May I ask you the question? Ma'am, this is a paid software or unpaid software?
I have shared a student license. So if you this student license, it is free for you. Because we are not practicing it, this is not commercial. I have shared a student license for you.
Okay, ma'am.
Otherwise, it is paid software only.
It's take a too much time because of lots of 891 MB.
Okay. If you feel like you can connect, I can help you in TeamViewer to install it.
Okay. Thank you.
Okay, ma'am. I think we cannot pull on the participants for more time.
Thank you so much, ma'am. It was really a wonderful session and hand-on training program. I guess participants have learned a lot, and in future, if they have any query, I will send question to you.
Yes, ma'am. We'll be
And
happy.
thank you for being with us. Really, your session is always motivated us to do better in this field. So stay tuned. We'll have 2 more sessions of Padmaja ma'am. On one is for MOs and another one is I forget the
NVO and Atlas.
yeah, and we were okay. So stay tuned. We'll meet tomorrow sharp at 12:30 p.m. Be interactive to gain more and more. If you are interactive only, then you can get. Otherwise, just sunenge or sab bhul jayenge. So be connected with your laptop because most of the part is on quantitative and qualitative analysis tools. So in case of tools, you need to be upload your tool, download your tool, and then do practice with the expert eminent speakers. Then only you will gain. Thank you so much again, ma'am.
Yes.
Thank you all the
Thank you, ma'am.
participants. Bye-bye.
Thank you.
Have
Bye,
a
ma'am.
good day. Stay tuned.